Good day, students. You're welcome once again to my channel. My name is Maduako Emmanuel, your favorite maths teacher. Today we shall be looking at a very important topic called variation. What is variation? Variation is showing the relationship between two or more variables. Now, the symbol for variation is this. It is also called proportionality. Alright, now remember I said variation is the relationship between two or more variables. For example, they might tell you that C varies as D, where C is circumference, of a circle, and D is diameter. Now look at this. This is a variable. This is another variable. This sign in between here is what? The variation or the proportionality sign. Now, when you are solving questions involving variation, the first thing you need to do is what? How to remove this proportionality sign. Now, to remove your proportionality sign, you introduce the equality sign and also a constant. So now I'll be introducing you to the constant of variation. Constant of variation. Alright. Now, anytime you are given a question and you are given the proportionality symbol, or you interpret the word problem and you introduce your proportionality symbol, which is also the variation symbol, the next thing you need to do is what? Take out that variation or that proportionality symbol, introduce your equality sign, and also introduce a constant. Normally we use constant K. You can use any constant as long as you define what that constant is. Alright. Now I will work with this. I am giving C directly proportional to D. To take away this sign, I will be writing C equal to, this sign has gone because I introduced equality, but I'll introduce my constant K. So this 2 has taken away this proportionality sign. Then my D. So it's C equal to KD. This is the equation for this. This is where this equation 1 finally arrives at. Then you now write where K is a constant. I'm sure you get that. Now, where K is a constant, don't forget that you have to define your other variables also. Now, we'll take an example. Example 1. Now, if I am giving an example and they said, if Y varies as X, show the relationship between Y and X. Alright, look at this. The question says Y varies as X. When they don't add any other adjective after the variation, just know it is a direct variation. They said Y varies as X, means Y varies directly as X. Alright, look at this. We show Y varies as what? X. I said to take away this, what do? I introduce my equality and what? A constant, X. So I've shown the relationship between Y and X. This is just what this question is asking us to show. Now we'll be going into further examples where we'll be attaching values to our variables, and then we'll solve the equation. Alright, now quickly before we go into the examples, let me explain the types of variation that we have before we focus on the one for today. Alright, the types of variation, we have the direct variation. Now, for direct variation means as one variable is increasing, the other is decreasing. as one variable increases, the other also increase, and vice versa. That is for direct variation. As one variable is going up, the other is also what? Going up. Now, for inverse, for the second one, inverse variation. As one variable is going up, the other will be coming down, and vice versa. Now, that's for inverse variation. For example of direct variation is the one we just did, where y varies directly as x. This is the representation. Then finally, you have it as y equal to what? Kx. This is direct variation. The second one is inverse. Inverse variation. Inverse variation, as one variable increases, the other decreases. Alright, look at inverse variation. Y is inversely proportional to x. It means y inversely proportional. The x, you represent it as 1 over what? X. If you introduce your equality sign and introduce the k, you'll be having k over x. This is the relationship for inverse variation. Then the third one is joint variation. Joint variation. Now, for joint variation, you are combining both direct and inverse. It means you are having more than 2 variables this time. You are having an additional 3. But one is directly proportional, the other one is inversely proportional. So for example, y directly proportional to x and inversely proportional to z. Now look at this. This is joint. I'm combining both a direct proportionality and an inverse proportionality. So if I remove this, I'll be having y equal to what? Kx over z. Don't forget all these are variables. K is your constant. Don't forget that. Alright, the fourth type is what? Your joint variation. It's called a partial variation. We'll be looking at this in detail some other time. Partial variation, very interesting. It's a variation that comes this way. Now, this is a partial variation where I'm having y to be proportional. Partial is c, is a variable, but because of this addition, it shows me there is a partial variation. I add another variable x. Do you get that? We'll come into this in details later on, but for now, we'll look at examples involving these three types of variation. Alright, now we'll take some examples on direct variation. Our example 1 is on the board. It says, if y varies directly as x and y equal to 6 when x is 3, find, question 1, find y when x is 7.5. Question 2, find x when y equal to 16.5. Alright, let's solve. Solution. Don't forget I told you always start with a solution. Alright, now we are giving what? Y directly proportional to what? X. To take out this proportionality, what do? Y equal to what? Kx. Where k is a constant. Alright, now look at this. We've arrived at this point. Look at your question. You are giving y is 6, x is 3. It means you are going to introduce it into this equation to get the value for your constant. A constant is a number that appears the same all through the equation, all through that question. It doesn't change. Alright, want to get this constant. Now, when y is equal to what? 6, our x is equal to 3. Now, let's term this equation 1. I will need to substitute these values into equation 1. Anywhere I see y, I'll put what? 6 equal to, this is my k, times my x is what? 3. So to get my value of k, what do? I'll divide both sides by 3. 6 over 3. So my k is what? 2. Now I've gotten my k to be 2, so I can introduce this value of k as 2 into this equation to have it as y is equal to 2x. At this point, you introduce k equal to 2 into equation 1. This is my equation 1. So now I have my y equal to 2x. So now let's answer our first question. Our first question says we should find what? Y when x is 7.5. I already have it that y is equal to 2x. So my y is equal to 2 times my x is what? 7.5. That is this first question. X is 7.5. Anyway, I say x, I put 7.5. 2 times 7.5 is what? 15. The second question says, don't forget we are coming back to this equation. This is our general equation now because we've gotten a value for k. The second question says find x when y is 16.5. So anyway I see y, I'll put what? 16.5 equal to 2x. To get value of x, divide both sides by what? What is with x, which is 2. So I'll be dividing 16.5 by 2. It will give me the value of x. If I divide 2 in 16 is 8.2 in 5, 2. Remainder 1 in 10, 5. So I'm having my x as 8.25. Alright, now we've solved that question. We'll be looking at question number 2, an example. Alright, we have our second example on the board. The second example says the resistance R in Newton varies directly as the square of the speed V in kilometer per hour. The first question says write down the relationship between R and V. Solution. Our first question says what? The relationship between R and V. Let's look at it again. They said the resistance R varies directly is this as what? As the square of what? V, speed. As the square. You can see it. R varies directly as the square of V. That is the relationship that exists. I need to take away this proportionality. I'll be having it as R equal to, introduce the constant K V squared, where my K is a constant. Let me divide my board into 2 so I can solve using this side. Alright, now we've solved the first question. This is the first question. That's the relationship that exists. Now the second question says what? If R is 600 and V 20, R 600, V 20, I need to find my constant K. So anyway I see R, I'll put what? 600. 600 equal to K. My V is what? 20. Don't forget the V is what? Squared. So I'll be having 600 equal to K. 20 squared is what? 400. So to get my K, I'll be dividing both sides by what? 400. Anything I do to my left, I do to my right. So that this will cancel this. So I'll be having my K to be this. 6 over 4, that's about 1.5. So I'm having my K to be 1.5. Now I've gotten my K as 1.5. I'll substitute this value of K into this equation. So that I'll be having my R to be equal to, anyway I see K, I put what? 1.5. Then I'm having my V squared. This becomes our general equation. That is the general equation for that question. Now, let's answer the question that follows. They said we should find what? V when R is 337.5. Now I'll come here, I'm continuing here. A. Anywhere I see R, I'll put what? 337.5. R, I put 337.5 is equal to what? 1.5 V squared. 1.5 V squared. I want only V to be on this side, so I'll be dividing both sides by 1.5. So I'll be having 337.5 divided by 1.5 to be equal to what? V squared. My V squared is equal to, if you divide this, what are you getting? Let me punch my calculator quickly. I'll be having 337.5 divided by 1.5. What did it give me? It gave me 225. 225. Now, I'm having v squared here. I need just v. What do? Remember when we did squares and square root? I'll be taking the square root of this. So square root of v squared, anything I do to my left, I must do to my right. 2, 2, 5. So that this square will cancel what? The square root. So I'll be having my v to be square root of 2 to 5 is what? Hurry up. Alright. 15. Alright, now we've gotten our v as 15. If you leave your answer like this, they will mark you wrong. Why? Because the question came with a unit. My v is given in kilometer per hour, so my answer must carry the unit, kilometer per hour. Don't forget, these are some of the little things that make students fail their exams. Don't forget to include your unit. Alright, we've solved the A question. Now let's solve the B question. I'll clean here and solve the B parts. I'm going to leave just our general formula, which is here. Alright, the B part of the question says we should find R when V is what? 32. Look at your general formula. R is equal to 1.5 V squared. So anywhere I see V, I'll put what? 32. So my R will be equal to 1.5 multiplied by what? Anywhere I see V, I put what? 32 raised to power 2. So that I'll be having my R to be 1.5 times 32 raised to power 2 means 32 times 32. And that gave me 1024. So my R will be 1.5 times this times 1.5. And that gave me 1536. Can I leave my answer like this? No. Because R came with a unit in the question. R is what? Newton. So I'll be putting in Newton here. N is the unit for Newton. Alright, now we've succeeded in solving 2 examples that had sub-questions. Alright, now I'll be leaving some questions on the board for you to attempt. If you are unable to solve any of them, you let me know in the comment section, and then in our next class, I'll be looking at that question and I'll solve it for you. Alright, the next questions you see on the board are your take-home questions. Alright, I have 2 take-home questions, 2 practice questions on the board. The first one says, if y varies as the cube of x and y equal to 6 when x is 4, find A, find y when x is 16, B, find x when y is 3. That's the first practice question. The second practice question says, the time of a pendulum varies as the square root of its length. Underline that word, square root, so you don't forget. If the length of a pendulum which beats 15 seconds is 9 cm, find A, the length that beats 80 seconds, B, the time of a pendulum with a length of 36 cm. Alright, so you are expected to solve these 2 questions. If you have any challenge with solving them, you let me know in the comment section. In our next class, we shall be looking at inverse proportion, inverse variation. We shall be solving examples on inverse variation and also on joint and partial variation. Now, at the end of this class, we shall be picking past wire questions that involve variation, and we shall be solving it also. Now, we've created a Facebook group. You would see the title on this. If you check the caption of this video, you will see the title of the Facebook group, so you can search it out and join, because we shall be using the Facebook group also to solve live questions. We shall solve it live so that we can attend to questions and feedbacks. Alright, if you know that you've enjoyed this class, click on the subscribe button and leave your notifications on so that you can be notified of our next video. I celebrate you.